Hello everybody, this presentation is about trustworthy adaptation with future learning for hand gesture recognition. This is a work between Concordia University and New York University. In this work, I want to first speak about the introduction, then we have the proposed Tfs Hdr Architecture. After that, I provide the experiments and result, and finally there is the conclusion. Here we have the motivations and contributions behind of this work. Actually, we provide a novel and innovative trustworthy few-shot hand gesture recognition, which is Tfs Hdr for the hand gesture recognition task. And the motivation behind it, behind this work is that in the recent literature where the others use deep neural networks, there is a poor performance if we have a small amount of data and we need the data for adaptation or a changing task. So there is a noticeable gap between practical setting and recent academic solutions because of two reasons. The first one is that the CMG signals varied from one users to another users or from one task to another task. And the second reason is that for deep neural network models, we need a very large and labeled data sets. So here the contribution of this work is that we propose a future learning framework that allows that myoelectric controllers that has been built on a background data can adapt to a new task with a small amount of data or with a few shot observations. And the second contribution is that in this work we use a combination of temporal convolutions and attention mechanism. So we propose a novel future learning architecture that first we can reduce the training time for a new user or for a new gesture, and then we can reduce the challenge of variability in the SEMG signals. Here we have the proposed Tfs Hdr architecture. Actually, we use three basic modules. The first one called temporal block module. In this module, we use dilated causal convolutions because in the causality allows us that there is no leakage information from future to the past, and we use dilation because by using dilation we can access a large history field. And then each causal dilation convolution is followed by a ReLU activation function, and after that we can concatenate the input and the activation function. The second algorithm called the temporal ComNet module, which consists of a series of the temporal block modules. Actually, this block has the number of the blocks that we use here is Z, that consists of temporal block module. And then we have the attention mechanism. In the attention mechanism, we have keys, queries, and values. First, we find the similarities between keys and queries. After that, we have probability. And by using the matmul, we multiply the probabilities in the values. And then we have output. Finally, we concatenate again the input and output. Here we have the experiments and results. Before that, I want to speak about the database. In this work, we use the Tfs NinaPro database, which refers to DB5. And actually, in DB5, they use 16 wireless electrodes, and the SEMG signals are collected with a rate of 200 Hz. And in DB5, there are 10 healthy people that they perform 52 movements, including basic movements of the fingers and, for example, wrist movements. And this database is public, so everyone can access to this database. And each movement in DB5 database is repeated 6 times, each one lasting for 5 seconds, followed by 3 seconds of rest. Then here we have the experiments. The first experiment is new repetition with few shot observations. So here we have the new repetitions, and we validate one way 1 shot, 1 way 5 shot, and one way 10 shot for two kind of embedding module. The first one is fully connected embedding module, and the second one is LSTM embedding module. As you can see, by increasing the number of shots, the accuracy is increased. The second experiment is a new gesture with few shot observations. Again, we have 5-way 1 shot, 5-way 5 shot, and 5-way 10 shot. Again, there is two kind of embedding module, FC embedding and LSTM embedding. And as you can see, by increasing the number of shots, the accuracy is increased. And for the FC embedding, we have the better result. So the type of the embedding module can affect the accuracy too. The unique characteristic of the proposed Tfs Hdr framework is as follows. The first one is that we evaluate the performance this architecture with DB5 database, and this architecture has the ability that adapt with a few shot observations. And this framework can transfer knowledge between a source and target despite the existence of distribution mismatch among them. And we evaluate the few shot learning when it is applied to hand gesture recognition. And in this experiment, we use two kind of embedding module. The first one is fully connected and the second one is LSTM module. And as you can see, it can be observed that the type of embedding module could affect the overall accuracy. Thanks for your attention.